Thanks, Ken, and thanks everybody for being here tonight. This has been a long time in the making. Ken has stayed after me. He's very tenacious and got me here, so I appreciate that very much. There's going to be some stuff that I talk about that's going to sound like Ken and I planned some things, but we didn't. This is kind of how God works. And the things that I'm going to talk about tonight, really, I want to give an overall breakdown of how should we scientifically look at the concepts of evolution. Evolution and creation are both these models that we have for origins and diversity. There's really only two. So one is right and one is wrong because they're both opposites of each other. And since they're models, kind of philosophical models that are attempting to explain how we got here, how everything got here, they need to be held to scientific rigor. And I want to make sure that we do this. It's going backwards. That's interesting. I want to make sure that we look at creation and evolution from a scientific standpoint and measure both of them up to see which one seems to explain the evidence better and make better predictions about what we actually observe. So these are the things we're going to cover. I'm going to go over just a little bit of my background only because I think it's relevant. Ken got into it a little bit, but it's directly relevant to what I'm talking about today. And then we'll talk about the power of a scientific model. What does a good scientific model look like? What does a bad one look like? We'll look at information as a scientific model, which it is now. And then, like I said, we'll measure the creation and the evolution models up against the information scientific model and see which one explains things better and which one doesn't. As Ken said, to me, this is the most important thing about me. I am, by the grace of God, a Christian. I will get into that a little bit, how that happened, again, because it's directly relevant to this. We do have 6 kids. They are all adults now, 4 grandkids. Hopefully we'll have a lot more on the way. We've been married for 34 years, 34 or 35 years. I'm not as old as this beard makes me look, but I like the beard, so it's staying. And I've been heavily advised not to dye it. So in general, my background, as Ken mentioned, I was not raised in a Christian home. I was raised actually in a Christian Science home, which is neither Christian nor scientific. And not heavily practicing that, but when I thought of church, I thought of a Christian Science church where for a while my mom sang. My grandparents were much heavier into Christian Science than my parents were, but that's what I thought of when I thought of religion. And that was, they do have the Bible, they do carry the Bible around, but they don't really look at it. It's really more of an accoutrement for them. And their big book is the Key to the Scriptures by Mary Baker Eddy. So it is really a full-on cult, which I had no idea when I was going, and I probably went, 15 or 20 times. So it's not a big part of my life, but that was religion. And my other experience of religion was my 2 best friends growing up. One was Catholic, one was Lutheran, and I used to enjoy their arguments about whether or not you can pray to Mary. That was very entertaining to me. I had no idea what they were talking about, but that was a very common set of arguments that they would get into. Now I get it, but back then I didn't. So I went to grade school, middle school, high school, secular school, public schools, had what I would consider the standard indoctrination education, teaching you what to think, not how to think, not how to critically appraise information and process it in a logical, straightforward way. That would never really sat well with me, and I would occasionally have problems with that, but generally I made it through school okay. I graduated from high school, I guess a committed evolutionist, only because I didn't know anything else. There was evolution, that's what is taught. There's absolutely no deviation from that in the schools. And so I had no reason to believe that evolution wasn't true. I entered UWM, University of Wisconsin-Milwaukee, where I majored in biological sciences, went heavily indoctrinated into evolution there. Again, I didn't really question it because it didn't really seem relevant. But I do remember one of the first classes that I had, sitting down in this big auditorium and listening to the guy up front talking about evolution, and he mentioned that, there was this guy named Usher that a few hundred years ago calculated that the Earth was 6,000 years old, and I thought, man, that's funny. But now I believe that, so, and I understand why. But that made a big impression on me, but I didn't really think too much more about it. After I graduated from undergrad, I thought I'd try research for a while. I worked in the bone marrow transplant lab for a year doing clinical bone marrow processing, and then some scientific research. Learned that that's not for me. I like a little more action than that, and so I went to medical school after about a year at Medical College of Wisconsin. While I was in medical school, I think it was our second year, either first or second year genetics, probably second. And I remember sitting in there and they're talking about mutation, talking about genetics, talking about variation, and it just occurred to me that every time they talk about mutation, they talk about how it damages the DNA. Even one mutation, you change one letter of the billions of the letters, it can kill the organism. And I remember thinking, how can you possibly get from a bacteria to a person when you're having this, relying on a process that all you can say is that it damages information? So I thought maybe they didn't explain everything well enough to us, and so I went and asked the teacher, asked one of our genetics professors about that, and I just said, I don't really get how this mutation thing works. How does it create new meaningful information and to drive evolution? And the answer was not a scientific answer, which is what I was expecting. The answer was, are you a creationist? And I'm like, dude, I don't even know what you're talking about. I'm asking you a scientific question, and you just answered me with a philosophical response. You seem to have a problem with your model. And that was the beginning of things for me. Again, by God's grace, He knows how I think. He knows how my mind works. And that was really the way to me. And after that, I went through a lot of stages. My wife at the time was kind of transitioning from Catholicism to biblical Christianity. And we were talking about things. I could not accept the 6,000 years. I could not. There's a lot of Noah. There's no way that story was real. Are you kidding me? You got all those animals in the boat. But I tried the progressive evolution. I tried the theistic stuff. I tried the day age. It doesn't work. And it doesn't work because it conflicts with what the Bible says. The Bible is very clear about certain things, how creation occurred. It's very clear that evolution is not factual because God says that's not it. So if you are going to believe this creation, if you're going to believe this Jesus thing, like He's your Savior, it starts in the beginning. It starts with Genesis. You can't step outside of that fact. So you're not in a safe place if you believe things that the Bible does not say, or even worse, if you believe things that specifically the Bible does not say. So sometime throughout medical school, this was a long process, but like I said, by the grace of God, I got where I am today, which I think seems to be on the right track. Postgraduate, I got done with medical school, medical school, and then I did a 4-year residency in physical medicine and rehabilitation. So that's my specialty. I'm board certified in that, and deal a lot with managing disability, pain management, neuromuscular conditions. I do a lot of EMG and nerve conduction tests, and really enjoy doing that, which I've been doing for over 20 years. And then, as Ken mentioned, I am a business owner. 15-ish years ago, we started a very small science curriculum companies for homeschool kids. So we started with biology and life science. It's called Science Shepherd. We now have kind of a full program, expanding out all the time, but we now cover from grade school to high school. And I that's really what I'd like to be doing full time, would be that. So if we continue to grow, that will happen. But my oldest son works for us, and so do my two youngest kids. So it's been a good run so far, and I hope it will continue to get better again by the grace of God. So one of the things Ken and I did not talk about was the scientific method. He didn't prime you for this at all. It's important to understand how the scientific method works, particularly because if any of you have been paying attention for the last 2 years, that's completely derailed. There is zero scientific method that has been undertaken for any aspect of how we're prosecuting this COVID nonsense. So what Ken was talking about is this is the scientific method kind of in a nutshell. And all I really want to point out with this is that it's supposed to be a rigorous pathway where scientists identify some type of problem, some type of observation, and they come up with an idea as to why would this be? Why do apples fall down to the ground? Why are we here? And then they figure out a way, with the experimentation, they figure out a way to explain, to test their statement. And so they set up an experiment, and they do whatever they're going to do in that experiment. And the idea is, as Ken mentioned, that you have a way, you're either doing that experimentation, it's set up specifically either to strengthen your hypothesis by collecting data that is consistent with it, or weakening it, or maybe even falsifying it, where you then throw it out, or maybe you restate it. But the idea is that you are continually working toward scientific truth. And you're trying to explain and collect data that either shows that your hypothesis is correct or that it's not. And as you experiment more and you find that your hypothesis is valid, more and more experimentation is done. You publish your results, it's shared, other people do it, do the same thing you're doing, or kind of an offshoot to add to the knowledge base of what you're doing, and then eventually you get to the point where the data is always consistent with whatever that hypothesis is, and then we call it a scientific theory. There's a lot of theories out there, some of them better than others. Evolution is a theory sometimes, a bad one, but because none of the data support it. But after you get a theory, you're not done. You continually test it and test it and test it and test it. And then once you get there, whatever you've been doing becomes a law. And we don't have that many laws in science. When you consider that we've been doing the scientific method for 300 years or so in this rigorous fashion, we don't have that many laws. And we're going to go over a couple of them. But the point here being, what I want to say here is that the law, I want to drive this home, that a law, you only get to the point of a law when you basically know that you cannot, there will never be any data that you can collect that will falsify that. That's when you get to the law state. So it's a big deal. And like I said, you publish these things, you share conclusions, because you don't have, unlike, Dr. I Am the Science, there's nobody that has the final say on what scientifically is accurate and what is not. People continually test things. It's way too frequent. People falsify their data. I have an entire talk on all of the falsifications that have occurred over the years and why we do this, because that's the only way that we can rat out the liars and the finks. And it remains this very rigorous way to test things and to either validate or invalidate others' work. The scientific method should be a really big deal. And kind of the foundation of this is that when you get to a point where you've got a law or you've got a scientific model that you have put in place using various laws, using various data and theory that you've collected, the stronger that model is, the more it can explain data, not only that you've collected, but that you will collect, the better the model is. And when the opposite of that is true, when it can't explain anything, the model is bad, and generally it's thrown out, generally. So the gold standard, really, of any model is its predictive ability. All models, all theories, all hypotheses, that's kind of what it's about. It's making predictions about the data that you will collect based on any experimentation that you could do. So the better it predicts, the stronger the model is. And I want to go over here, this has nothing to do with information, but I think it's important to walk through to see what a good model looks like. And to do that, we're going to talk about the discovery of Neptune, which was officially credited in about 1846, but it might have been in 1830 or 1821 or 1795, or maybe even in 1609. And the reason I say that, I hope will become obvious when we get to the end, but this is the story of the predictive power of an excellent scientific model that relies on multiple proven laws that we still don't argue with. It starts with Johann Kepler, who between 1609 and 1619 wrote the laws of planetary motion, that he figured out just by looking at the way the planets go around the sun. The planets known at that time, we knew about planets all the way up to Uranus, but we didn't know about Neptune. But he basically discovered these mathematical relationships that exist between planets and stars and the sun, and how they go around and how they affect each other, and he was able to quantify them in mathematical models, in basically equations. And that's what we call the laws of planetary motion. And at about the same time, Galileo, right around the same time, saw Neptune, but he didn't realize it. He was looking at the stars through his telescopes that he made, and he was looking at Jupiter, which is right here with its moons, and he saw this thing over here that he called a fixed star. This is in December 27, 1612, and he saw this right here, and he called it a fixed star, but that's Neptune. And how do we know that's Neptune? Because we can use the excellent laws of planetary motion, the laws of gravity, the laws of Newtonian motion, which I'm going to talk about in a second, and basically wind the solar system backwards to 1612 and say, yep, that's where Neptune would be in 1612. So that's why we know that's Neptune. He didn't realize it was a planet, we don't think. It's actually not very clear. But shortly after that, Isaac Newton came along and he figured out the laws of motion. He discovered the laws of motion that were created the instant that God created matter and mass. And so he figured these out. They're similar to the laws of planetary motion, but they're different. But these are still relationships that exist between two objects, and they're mathematical relationships. So he writes these equations down, and then other people can test the equations that he writes down to see if he's right or not. And so they're tested over time, and they're found to be true, accurate representations. Then as we move through, we still didn't know Neptune was a planet yet. People have seen it a couple times, but they think it's a star. Jerome Lalande and then John Herschel. John Herschel's the son of William Herschel, the guy that made these massive telescopes in England. So he was, like his dad, loved looking through telescopes, and his mom, or his sister, I guess his aunt. I think it was his aunt. Anyway, so these guys both saw Neptune. They clearly mapped Neptune. They were looking at it through their telescopes, but again did not realize that it was a planet. Jerome Lalande in 1795 and John Herschel in about 1820. And then Alexis Bouvard comes along in 1821, and he makes tables of Uranus. And what a table of Uranus is, or a table of any planet, is it's basically a table that, using the laws of motion, using the laws of gravity, using Kepler's laws, you can calculate where a planet is going to be at basically any given point in time. So he makes these tables, and in 1821, and shortly after, as he's watching Uranus after he makes these tables, he notices that Uranus is not exactly where he thinks it should be. So I assume, I don't know, but I assume he rechecked his calculations a couple of times and realized, yeah, I'm right. It's something is not right here, and so he proposed that the reason his tables are off is not because there's anything wrong with the laws of motion, with the laws of gravity, etc., but because there was something farther away, something big, farther away that we couldn't see that was disturbing Uranus's orbit. But he surmised it was a planet, but he wasn't sure. And then within almost days of each other, these two fellows, Urbain Le Verrier and John Couch Adams, using mathematics, figured out that, yes, there is something outside of Uranus that's messing up the orbit. It's a planet, these are its properties, and this is where you can find it if you take your telescope and look at it. So Johann Gottfried Gaillet, very soon after that, took his telescope and found Neptune. It had exactly the properties that they expected it to have. Why was this so good? Why is this such a good example of what the scientific method is and how good a good scientific model is? Because it was said that Leverrier, Adams, maybe even Bouvard, were the only people that ever discovered a planet with a pen. They used the mathematical relationships that are built into these laws and figured out these various properties of Neptune and exactly where it should be, given the perturbation of Uranus's orbit. So that's all because of the excellent work that had been done for the 200 years prior to that, testing the hypotheses of Kepler and of Newton, and continually talking to each other and going through this to explain why is Uranus's orbit not what it should be. We all agree that my tables are right, but yet they're wrong. Why is that? That's the intersection of excellent scientific models, multiple scientific models with multiple laws, getting us to a really good place. And now for a model that is pathetically and continuously wrong, and yet we are hammered with it every day, is climate science. So I'm only going to spend a small amount of time on this because it is a horrible model. It is provably a horrible model, and I don't want to make any of you stupider by talking about it too much. So any of you who are old, like me, will remember back in the 60s and 70s, we were going to have an ice age. Initially, it was by 1980. But throughout the early 70s, it was not really progressing the way the alarmists wanted. And so they said, no, it's going to be more like the 2000. Well, obviously that didn't happen. Then, do you guys remember the acid rain? Really? It was going to kill all of our crops. It was going to kill all of our plant life. It was going to kill all the organisms in any bodies of water. And then the government actually did a study on it, and by 1990 they figured out it's not that big of a deal. Then in 1988, the alarmists were telling us we were going to have massive regional droughts. Those never happened. Then the children in 2000. Now we figured out, okay, it's not getting colder, so it's getting warmer. And one of the effects of this massive warmth, besides, of course, Florida being underwater by 2010 and all this other stuff, children in the UK will not know what snow is. How sad. They won't know what snow is. This is 3 months ago in the UK, where they were snowed in this pub for 3 days. So this is a horrible model. It's continuously wrong. The reason that it was global cooling and then global warming and now it's just climate change. Can't go wrong with climate change, right? Because the one thing that we know the climate does is change. So we're going to stick with that. That's why it's a horrible model. They have no idea what they're talking about. All of the predictions into the future are based on computer models that are programmed by human beings, and you program your bias into the model to give you exactly what you want. That's why we were going to have millions and millions and millions of people dead in the COVID thing, because they programmed that computer model to give them that answer. So we're going to look now using good science. We're going to look at the predictive and explanatory abilities of scientific models, and to reinforce, the better the model predicts and explains, the stronger it is, and the better the model agrees with other models, the stronger it is. So we're going to measure the two origins models, creation and evolution, under the light of information. And the first thing, I just want to very briefly go over this, the evolution origins model. Time solves all ills in that model. So we don't really need to have any specific mechanisms. We don't need to have any proof, any data that shows what we're talking about is true, because all we have to say is time fixes everything. You can't test a model that takes billions of years to occur. So this is the solution. Time is a solution to any argument you could possibly give. But we've got the pond scum that somehow transforms, single-cell organism transforms into multi-cell organism, multi-cell aquatic organism transforms into a multi-cell land organism, and then like the reptile transforms into birds and mammals. That's really an interesting story. I remember when I was in school, they would have these really great pictures that would show how this can happen, and if you don't think about it any farther than cartoons, this seems pretty valid. But when you think about it from the standpoint that you must think about it, is from an information standpoint, you realize what really needs to happen. For this to occur, there are very specific things that need to happen in our blueprints of life, in our DNA. So you've got these, you have this, you start out with a single-cell prokaryotic organism, that's bacteria. I'm not even going to talk about how that organism formed in the evolution model because, again, they have absolutely no rational scientific explanation for how it formed by itself. But let's assume that it did form. So you've got this single-cell organism. This is not a prokaryotic organism. So don't anybody say, "Hey, that's not." I know that this is duckweed. So anyway, it's just my picture for this. So we've got the single-cell organism that is a prokaryote, an entirely different cell structure than what we and all multi-cell organisms have. It's very different. But the point is that the DNA, the instructions for how to make that single-cell organism, is built into the DNA. And so when that DNA gets read, every single time that DNA gets read, you're going to have a prokaryotic organism. Just like the one that it came from, it's going to make more just like copies of paper, one after another. So the only way to make that not happen is you need time, and then you need something to happen to the information in that organism's cell. You need there to be a process that causes that information in that organism cell to change. And not only can it just have to change, it has to change in a very specific way. It has to change so that it's gaining information, meaning information. When I use gaining information, I'm talking about new traits that previously did not exist that will cause it to transform into something that it's not. So a prokaryotic organism, the single cell had to gain information that caused it to develop a nucleus, that caused it to develop a whole bunch of different things inside of the cell that a prokaryotic organism does not have. That information had to come from somewhere. And then once that happened and we got the first eukaryotic single cell, then we needed more information to get added in there over time. Over time, as these organisms reproduce and reproduce hundreds, thousands, millions of times, every time reproduces, you need to get some type of information adding into that new ancestor organism that's now going to transform into a fish. So it has to develop somehow the DNA, the instructions to build a fish. Those instructions never existed before. They had to come from somewhere, and those instructions are supposed to come from the process of mutation, because that's the only thing that we know that can change DNA. Now, again, we won't get into the fact that anytime we change DNA, we generally kill the organism or make it sterile, but let's ignore that and say that that's the process that has to happen. And not only does it do that, but it has to create information that will cause a brand new, never before in existent organism to form. So now this fish has to get up on land, and over time, millions and millions of years, as these little ancestor organisms divide and reproduce, they need to gain more information that will allow them to go from a 2-chamber fish heart to a 3-chamber amphibian heart. They need to go, which also, by the way, completely changes the direction of your blood circulation. So now, because you're going to have lungs when you live on the land, so now you have an entirely different circulatory system. That had to come from somewhere. You had to get these little fins to turn into feet. Again, the pictures look very convincing, but if you don't have a process to generate new DNA, to generate this new information to cause it to transform into an amphibian, and yes, I know this is a reptile, I'm getting to that in a second, but if you don't have the information for a fish to transform into an amphibian, you can't have evolution. And then once the amphibian comes, same thing happens. It transforms into the reptile. And then the reptile, when you think about this, it has to gain more information to turn into a mammal. This process is called Neo-Darwinism. The idea, see, Darwinists didn't even know about this. Unfortunately, if they would have known about this, we probably wouldn't have Darwinism. But he came up with his idea before everybody became aware of Mendel's work in genetics. And once they became aware of it, they're like, man, we need to figure out something to explain how evolution occurs. Let's call it Neo-Darwinism, and it's going to be mutation that fixes this. Okay, that's great. So let's think about how that's going to work, though. Sometimes when I do this, I try to think about this with kinds in mind. I go back to the creation idea, but we can think about it just from how does a reptile get to a mammal? And I think about the defining characteristics. What are the defining characteristics of a reptile? They have scaly skin, they have a 3-chambered heart, they're cold-blooded, they have tiny brains, they don't have really any parental care of their young, blah, 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 lots of other things. So all of these characteristics are, of course, encoded in their DNA. It's in their information of life. So when you take a reptile, our experience is obviously always, whenever you take a reptile and make it reproduce, you always get more reptiles that look exactly like this. But time, see, you got time. You can't do your little experiment creationist over millions and millions and millions of years. If you had enough time, you would see that this indeed would undergo evolution. So the idea then is when you've got this reptile reproducing many times over millions to tens of millions of years, there's going to be information that gets into its system and causes it then to be able to develop hair, a 4-chambered heart. It's going to be warm-blooded, so it's going to be performing bazillions more chemical reactions inside of it than the reptiles are. All of this stuff is encoded in the instructions in the DNA, and the only way for that information to get there is through mutation, some type of mutation. But that's the process. So when you think about a fish going into an amphibian, going into a reptile, going into a bird, and then the reptile going into the mammal, you got to think about how do you get from one kind to another? You have to, losing traits, not that big a deal. You have a mutation, it's gone. That's pretty easy. Getting new ones, that seems to be impossible since nobody can do that. So keep that in mind when we're talking about all of this information. So when you think about now how that occurs, again, I've mentioned it multiple times as being mutation, but the only thing that's allowable in this model is the materialistic and naturalistic explanations. There's no God, there's no direction, there's no purpose, there's no intelligence. It's purely the statistical processes of random mutation. So the evolution built into that is in that model, built into that Neo-Darwinian model that fuels evolution is that materialistic processes created meaningful genetic information to cause evolution. So these materialistic processes that were not intelligent, that had no purpose, is what created the information to cause a reptile to transform into a mammal, that created this information. This is Charles Darwin, wrote this famously in one of his notebooks, basically just lamenting at the state of his model in the late 1830s. "O you materialist, why is thought, being a secretion of brain, more wonderful than gravity as a property of matter?" He was very aware that his model was completely divorcing God from science, and that had heavy implications, not just on him personally, theologically, which by this time he was an atheist, but also on just the scientific world in general. That he was going to meet great resistance, and this is the main reason that most likely that he did not publish his idea for 20 years. So the creation model, if we talk about that, in our model, we've got the all-knowing, all-powerful God of the Bible created everything in the universe in 6 days, just like it says, by saying, "Let there be." Now, baked into that, there is a ton of things that are baked into that, especially from the information side. So from the information standpoint, God created all the kinds to reproduce after themselves. That means that God, at the sound of his voice, speaking the words, "Let there be," he created all of the content, the information that those organisms would ever need to fulfill whatever purpose he had for them. Whether they were dinosaurs or people or birds or whatever, the information content was created when he spoke. and would provide any of the need that could ever possibly happen. So information is the key here. And when we think about that, where did everything come from? There has to be a way to create the diversity that we see on the planet. If you're a creationist, that came from God speaking the words, and then natural selection does its thing. Yes, we believe in natural selection because it doesn't fuel evolution. It can't do what evolution does. But it's an observable scientific phenomenon. Don't be afraid of natural selection when it's explained and understood in the scientific way that we can all observe. But it cannot fuel evolution. That's very different because natural selection only acts on existing information. It doesn't create new information. There's a huge difference there. But you have to have a process that creates new information from an evolutionary standpoint to be able to allow a bacteria to transform into fish and trees and mammals. There has to be a process. So what predictions are these going to make? So we've got the evolution model, Neo-Darwinism, that says nature alone created the meaningful genetic information that allowed bacteria to transform into people and everything else. So the prediction in that model is that material processes, since that's what Darwinism operates under, material processes can create meaningful genetic information. No intelligence is required. The creation model is the opposite of that. In our model, it's the intelligent designer that created everything, including the information, to make everything. And so the prediction of that model is that material processes cannot create meaningful genetic information. You must have an intelligent creator, otherwise God wouldn't have had to do the things he did when he created everything. So information and origins and diversity are intricately linked. Now let's measure these up against what we see. So I'm going to be talking about information science, and if any of you are concerned that maybe this is one of those crazy creation things that the real scientists don't believe in, this is the first 6 words of the entry for information theory from the scientific hotbed of Wikipedia. Information theory is the scientific study, and that's what I'm talking about. Is information theory, whether you want to call it information science, doesn't matter, it's the same thing. So even Wikipedia agrees with us. There are more than 400 academic institutions that give out degrees in information science. In 2020, there were more than 18,000 degrees awarded in information science, and this is the things that it looks at: probability theory, statistics, computer science, statistical mechanics, information engineering, and electrical engineering. So it's a thing, all right? It's a thing, it's a recognized science. There's no evolutionist, no secular scientist that will argue with this from it not being because it's not an information, because information science is not a real science. Information came from the late 1930s and early 1940s from the work of Claude Shannon, unfortunately an atheist, but a brilliant man. This is the title of his master's thesis, which is largely considered the most important master's thesis ever written, because this is why we have computers. And it's not really even have that much to do with information. That was later. So he was busy. He was a busy boy and did a lot of really important things. But what he looked at, for the first time, he looked at the statistical assessment of information. Again, purely from a probability standpoint, that's what statistics is. And what that means is he would look at coded message systems. So when you hear code, don't automatically think of the spy, the CIA spy writing a code and then sending it to the CIA headquarters, although that is a code. A coded system is simply a system that is agreed upon, that you have an agreed upon understanding of how you're going to communicate. English is our code. That's our coded message system. If you are German, then German would be your coded message system. If you are a bird, a robin, then the tweeting that you make is your coded message system. That's the terminology to identify that you're talking about an information system. If you have a coded message system, it's an information system. So what Claude Shannon looked at is he would look at this, And he would assess the information contained in this based on the probability that these characters would appear in an English sentence. So when you think about this, M is more likely to appear in the English language than X. So X gets a higher information rating than M. And then A is more likely to appear than X or M, so A would have the lower information rating assignment as compared to X and M. Now, if you don't understand that, that's okay, because I don't either. That's not the point. The point is that he was very effective at looking at the content of information in coded message systems by doing this. It was a very effective method. He was very instrumental in helping the United States government decode German messages during World War II because of how he looked at information. But when you look at it from a probability standpoint, that's really just quantifying. What's the quantification of that information? There's way more to information than that, right? When you think about English, if somebody could speak that sentence, what have they communicated to you? Nothing, right? Because this does, as far as we know, this doesn't follow any of the laws of our coded message system. So was it received by the receiver? If it was, did the receiver understand it in the way that was intended, and did the receiver respond in the way that was intended? All of this stuff is inherent in information systems. It's not just about probability, the statistical value of a particular character within the code. So we can look at it like this. Let's say that you've not been outside today, and your friend who was outside comes over and says the sky is blue today. So he's communicated to you in our understood communication coded system, right? This is a coded message using the English code. It says the sky is blue. Use the sentence structure that we understand. This seems to be pretty obvious. Has communicated a message to you as the receiver. He's the sender. And what do you picture? Something like this? So his intention by telling you this, you didn't know, but his intention was he wanted to let you know what it was like outside so you could plan accordingly. And so, okay, the sky is blue. You conjure up this nice blue sky in your head, and you go outside and you see this. And you're like, what? You told me the sky was blue. Yeah, it is blue. It's crying. So even though we understand this message system, we don't understand the message system. That's the point, is that there's lots of things that are baked in to information when you're talking about a coded message system. So Werner Gitt was the director and professor of information technology at this German Federal Institute. The first thing to realize is, operating within the German system, very precise, very specific things. In order to get this title of director and professor, there's criteria you have to meet, including you have to be a published scientist, and you have to have scientists reporting to you kind of officially in your role. And he obviously is both. He's also a creationist. And he respected Claude Shannon's work, but he also realized that Claude Shannon's work leaves some stuff to be desired when you're talking about what does information really look like. Because when you're working within the coded message system, the statistical content of information is very different than what does the information actually attempt to communicate. And so that's what he did. He wanted to break that down for us. And he developed these 5 levels of information. The statistical is the first level, and that's the level that Claude Shannon devised. But then he came up with syntax, semantics, pragmatics, and epibetics. I'm not going to get into these other than to say that the point here is that information cannot exist unless these criteria are met, and vice versa. When all of these criteria are met in a coded message system, that is an information system. You cannot escape that. There are no instances of any coded information system where the information does not meet all these 5 levels. So if you have a coded message system that meets these criteria, these 5 criteria, you have an information system. And then he went even further and came up with laws of information. And like we talked about in the beginning, a law is a very big deal in science. Information science is a real science. He made these scientific laws because scientific laws, remember, are things that are always true. They've never been proven wrong. And that's still the case. So there's no known deviation. So we came up with these laws of information. A material entity cannot generate a non-material entity. Information is a non-material entity. And we'll get into this in a second. This is a little bit what Ken was talking about a few years ago when he did his talk. Information cannot be created by statistical processes, and information can only be produced by an intelligent sender. I think you see where I'm going. These are laws, scientific laws of information that have never been violated. So what? All right. Well, so what indeed? So, just very briefly, how do we work? We work, and all organisms work, because the information content they need to work, that they need to reproduce, that they need to function, is built into their DNA. It's on the inside of the DNA. It has to be opened up. It has to be accessed. In eukaryotes, like us, we are eukaryotic organisms. That means we have a eukaryotic cell structure with a nucleus, a whole bunch of stuff in our cytoplasm. But what that means is the DNA is all by itself protected in the nucleus because it's important stuff. So the DNA, if the DNA has all the instructions for what the cell is supposed to do, but it's inside the nucleus and nothing else goes in there, how does it get its message out to the rest of the cell for it to instruct the cell what it's supposed to do? It sends a message in messenger mRNA. The messenger mRNA takes the code, copies the code faithfully from the DNA. It comes out into the cytoplasm. And then once it's out here, it goes and meets a ribosome, and the ribosome decodes that message. And I am using language that is taught in every single secular genetics class that you can find in any university or high school. The ribosome decodes that code, and then it makes a protein based on the code. It's a faithful reproduction of the code. Generally, occasionally there's an error, but not very often. But the point is that this is the message coming from the DNA out, coming from the DNA inside, the message comes out, it's decoded and has an action. The ribosome is the receiver of the information, has the action, is receiving the action, the instruction from the actions from the DNA, and then executing them in a faithful manner. This is a coded message system. The DNA is the store of the coded message. It's transmitted, like I said, via the RNA, and then the receiver is the ribosome. This is a coded message system, therefore this represents an information system. The system meets all 5 levels of information, so there's no arguing that this is not a coded message system. It clearly is a coded message system, and again, this is not debatable by any secular scientist. This is a coded information system. So, I also stole this from Ken's talk. Every single cell is packed with coded systems. What we just talked about is called the genetic code. It's always been called the genetic code, but there's other ones here. And again, my point is not to go through them in any detail, but to make the point that all of these coded systems show the 5 levels of information, therefore they're coded systems, and yet they exist here inside of the cell. Therefore, they are responsive and subject to the laws of information because they are a coded message system. So I just went through all that stuff on that last slide. So now we're going to measure things up with the evolution model. The prediction, again, Neo-Darwinism, which is a purely material process, can create meaningful genetic information. It has to. If it can't, then evolution can't occur. So the first law of information says, or one of the laws of information says that information is a non-material entity. Non-material entities are like abstract things. Ken, in his talk, mentioned mathematics. If any of you saw that, I enjoyed that very much. Mathematics is a non-material. Language is non-material. Music is non-material. A lot of logic is non-material. So genetic information is a non-material entity. Another law of information says a material entity cannot generate a non-material entity. Well, we just learned that the material processes of Neo-Darwinism is a material process. Neo-Darwinism is therefore invalidated as a scientific mechanism because it requires It requires the material, the genetic material, it requires that genetic material, the non-material genetic material, is generated by a material process, and material processes cannot generate non-material entities. But wait, there's more, because there's more laws of information. So I want to see, we've already invalidated it because it's already violated one law, but let's see if we can go even further. So material processes are statistical. Again, Neo-Darwinism operates through statistical processes. Law of information says information cannot be created by statistical processes. Obviously, Neo-Darwinism is invalidated again because it violates this law of information. It's a coded message system subject to the laws of information, and it's violated another law. It's not a valid scientific, Neo-Darwinism is not a solid scientific method, and wait, there's more. There's another law of information. Material processes are non-intelligent. They're not, there's no purpose to them. They just happen, and then whatever's going to happen as a result of them happening happens. Law of information says that information can only be produced by an intelligent sender. A material process is not intelligent. So Neo-Darwinism is invalidated by the final law of information. Now, we aren't the only ones, and when I say we, I mean creationists in general. Lynn Margulis, very well-known evolutionist, wrote lots and lots of biology textbooks. I think I had at least 2 of hers in my career. Married to Carl Sagan. I was taught over and over again that the accumulation of random mutations led to evolutionary change, led to new species. I believed it until I looked for evidence. That is true of almost every evolutionist that believes in Neo-Darwinism, because you're programmed to believe it happens, you don't question it, and you move on with your life. Stephen Meyer is one of the biologists that was at a meeting several years ago in Great Britain, where this was a meeting not called by creationists, by the way, that was called by secular scientists to discuss the growing problem of Neo-Darwinism. They know this does not work. The technical literature in biology is replete with world-class biologists routinely expressing doubts about various aspects of Neo-Darwinian theory, and especially about its central tenet, namely the alleged creative power of the natural selection and mutation mechanism. That's what I'm talking about. They know that this is false. And yet it's in every single book, every single genetics book, biology book. We are constantly taught a lie, and they know it. So, as we've seen, the materialistic Neo-Darwinism model is invalid because it violates all of the laws of information. No other known information system violates those laws and is considered an information system. Therefore, evolution itself is an invalid origins model because it has no mechanism to explain the diversity of organisms that we see on the planet today. But I'm not just going to leave it at that. I want to go through things from a creation standpoint, because if creation really is the result of God speaking, like we think it is, that means very specific things. But one of the things that it means is that in our system, all of the laws of the universe that we have ever discovered or that we will discover were created by God when He created things. So God cannot violate His own law. I shouldn't say cannot. He could if He wanted to. But these laws that He creates are baked into His creation. So everything that we see and measure should be consistent with the laws of information that were created when He created everything. So the law of information is that information can only be produced by an intelligent sender. Well, all right, do I just want to say that's God? Why would I just say that's God? There's got to be proof that that is true. And this could be like 10 lectures, but let's just say that the Bible is consistent all the way through. It doesn't contradict itself. It's got bazillions of prophecies that have come true, some that we're waiting for soon, maybe. But there's no reason to believe that the Bible is not 100% accurate. So the Bible tells us that God spoke everything into existence. It says it's all-knowing. Some people say the Bible doesn't actually say that God is all-knowing. Well, it does too. Who is perfect in knowledge. The only way to be perfect in knowledge is to know everything, because if you don't know everything, if there's only one bit of information that you don't know, you know all the other bits of information, your knowledge is not perfect. His understanding is beyond measure. God's understanding, his knowledge is complete. He is certainly intelligent. So we'll go back to our prediction that information can only be produced by an intelligent sender. God is the intelligent sender because he's the only one that has perfect knowledge that could create the knowledge to create and sustain life. But we've got more, right? The law of information tells us that all information, and genetic information, is a non-material entity. Another law of information says that a material entity cannot generate a non-material entity. So what do we need? We need God to be non-material. Right? Well, what does the Bible say about God? God is spirit. Okay. There we go. It's throughout the Bible that God is an eternal spirit. He's got the Holy Spirit. So clearly God is not material. He is spirit, which is non-material. So let's go back and plug that in. I'm sorry, I don't mean to offend anybody by referring to God as a process. It just happens to fit into what we're talking about here. So God is more than a process. But he is non-material, therefore the fact that he could create non-material information is consistent with the laws of information. The final one, information cannot be created by statistical processes. Well, let's wait a second. Is God statistical, meaning does he have purpose? Or is he just kind of a random God without order? So obviously inherent in God's intelligence, when you are perfect in intelligence, you're not going to do things that are without purpose. But what does the Bible tell us? The Lord has made everything for its purpose, not just people, not just fish. Everything has been made for his purpose. That's what we would expect to see documented in the Bible if God is a purposeful God. He is certainly purposeful. So we'll plug this back in. Information cannot be created by statistical processes. God is not a statistical process. He is the purposeful and intelligent creator. So the creation model violates no laws of information because God, as described in the Bible, meets all of the criteria that are necessary to be the creator of genetic information. As we would expect, the Bible and God would not violate his own model that he created. Now, purely scientifically speaking, I put that into parentheses only because we don't need science to prove this, right? We have the Bible that tells us exactly what God did and how he did it. But that does not mean that we would not expect to see that the Bible continually proves what we see in science, and science continually proves what the Bible says. And that's the point of this slide. Neo-Darwinism violates all laws of information, therefore it is an invalid scientific mechanism to explain biological diversity. Since the evolution model relies on Neo-Darwinism, the evolution model itself is invalid, scientifically invalid. We can invalidate the evolutionary model many ways. This is one of them, but many ways we can absolutely invalidate it. From a creation standpoint, again, purely scientifically speaking, it violates no laws of information, so the creation model is a scientifically valid model of biological information, origins, and diversity. And that's it.